Good afternoon all. I have made this. It's a 4S2P, 4 in series, 2 in parallel lithium ion battery pack, and I've added this active cell balancer, 5 wires onto all of these 4 cells so that we can see when the cell balancer decides to transfer energy between the groups of cells. Now you probably noticed that cell 3 is a dodgy cell. In fact, it's a pair of cells in parallel, but they are those iffy eBay ones which have very low capacity, probably 300 or 400 milliamp hours, much lower than the 1.3 amp hours of these greeny blue cells. So what I'm hoping is if I draw a current through this output connector, or of course it could be an input connector if I want to charge the pack, then the voltage on this cell 3 should fall more quickly than the others because it has a lower capacity. And then the active cell balancer will kick in and we should see, well, by my reckoning, an attempt by the cell balancer to transfer from 4 to 3, because 3 will be the lower voltage, and from 2 to 3. So we should see these right-hand 2 LEDs come on to show that those transfers are taking place. Unfortunately, this thing doesn't show you the direction of transfer, which would be nice, but it doesn't do that. So before I connect a load onto there, and my load will be these 3 light bulbs all in parallel, I just want to show you this little voltmeter. And this is one that has the 2 separate connectors, which is really handy because you can put a power supply on the power supply connector. And I've got a battery here. This is a little 9-volt rechargeable, so I'm going to connect that up, which is that way around, and this thing comes on, and then there's a separate connector for the actual voltage measurement. Well, I've put this connector on cell 3, which is the dodgy cell, the one that should drop in voltage more quickly. So let's put that on there, and we can see that cell 3 is 3.61 volts. So let's blue tack this onto here so that we can see it. And then I want to, now I have ordered some more of these, but obviously I don't have them yet, because ultimately I want to be able to show the voltage on all 4 cells, and then we can see where these transfers are taking place. But for the moment, let's try it just on cell 3. So when I connect the lamps, now the lamps are connected across the whole pack, so all the cells should fall in voltage, but cell 3 should fall more quickly just because it has a lower capacity. So let's put my load on there. I'll take that out of shot. And we can see that's falling. And we can see that the lights have come on, but something really weird's happened. The lights have come on transferring from cell 1 to 2, or maybe 2 to 1. I'm not sure. This bulb's still on. It's certainly doing a transfer from 2 to 3, or it could be from 3 to 2, but I can tell you it isn't, because this is the one that will have fallen in voltage more quickly. Yes, it would be better if I had a voltmeter on each cell, wouldn't it? But also the lights come on because there's a transfer going on from cell, presumably 4 to 3. So I think 4 is now transferring to 3, 2 is transferring to 3, but I'm not quite sure why there's a transfer from either 1 to 2 or 2 to 1. I don't quite know why that's happening, and only when I get my voltmeters on there will we be able to see. Let's take this load off and see how quickly these lights go out. In other words, how quickly this cell 3 recovers. That's climbing up in voltage, probably partly because it's recovering from having the load on it, and of course also partly because cells 2 and 4 are presumably having transfers in to cell 3. Okay, 4 to 3 has gone off as we watch cell 3 come up. So I'm still not sure about this cell 1 to 2 or 2 to 1, and you can imagine that will stay on longest because these cells are higher capacity cells, so it's going to take longer for these to transfer. But yeah, I still don't understand that. I've ordered 3 more of these, and I've ordered them in red, blue and green, so we can have a different color display. This one's yellow for each of the 4 cells, and I'm going to have to make up a little panel to hold all 4 voltmeters, and I'm going to have 4 little 9-volt batteries, because of course these can't be at the same potential because these cells are not at the same potential, so these things are all going to have to be separate power supplies for each display. But that's not gone off yet. And I'm also getting strange flashing messages. I can't remember what the flashing means. It means something. I have to look at the datasheet again. Cell 3 to 4, there's some issue with it. Not sure what. Transfer is still going on between cells 2 and 3, and also between cells 1 and 2. I mean, is one of these got really low and it's falling away when I put the load on it? I honestly don't know. So let's just leave that running for a bit while I sort of talk about something else. I've got this precision voltage chip here, which can produce a very precise 2.5, 5, 7.5 and 10 volts. It's set to 5. So let's power that up with 12 volts or thereabouts, 13.1 actually. And I've soldered on a connector here specifically for this. If I take this off and take out its measurement plug, that should say 0, it does. Let's put that there. And I'll plug this into here, and this is going to enable me to check these voltmeters when I receive them on eBay and see how precise they are. Well, the 5 volts is let's move this over a bit, 5.001, so that's not bad. Let's take these 2 links off. These links are in parallel, they're just designed to provide a lower resistance. If you take them off completely, you get the equivalent of plugging them onto that one, which is 10 volts. That's 10.000. Let's put them on the 7.5 volt range and get them both on, and that's 7.498. If you put them on the 2.5 volt range, oh, those lights have gone off. You get 4 decimal places, so that doesn't look terribly accurate, but it's 2.498, and then that digit is 3. The listing for these things says give it 30 minutes to warm up, but it doesn't seem to make much difference to the voltage that's being shown on here. But yeah, the transfers have stopped, and presumably the voltage on cell 3 has recovered. So as I say, I'm waiting for 3 more of these. I can check them all on this little precision voltmeter rig. Let's put them back to 5 volts. And so yeah, this one is a perfectly good one. I can check the other 3 when they come in. And then if I remove the measurement cable from there and plug it back into here, we can continue to measure the voltage. As I say, this one is connected across cell 3 with the red and black wires there. So yeah, just waiting now for more of these, and then we can watch the voltage on all 4 cells and watch the action of the active cell balancer. But that's about all I can do with this at the moment. I suppose I could also charge this up, connect this to a power supply and raise the voltage on these 4 cells. And of course, if I do that, the voltage of cell 3, it being a lower capacity cell, will come up more quickly, and then of course the active cell balancer will kick in for that as well. Well, now I've just found this cable, which is a couple of 4mm bananas to a 2.1, so I can plug the 2.1 into there, and these were in the box for my power supply here, so I can put some diodes to protect the power supply, because although I've been connecting storage devices, particularly the capacitors, directly to these power supplies, I don't think I've done it with this one yet, so I won't do it today. I'll just put some protection diodes in there, and then I'll try using this, which is set to 16.5 volts. That could go a bit higher, but I've got to be careful because it'd be very easy to take that 3rd cell up above 4.2 because this isn't going to voltage limit if this one shoots way ahead of the other 3. So let's just wire this up and start charging this bank. So with these 2 diodes, we've got positive current, conventional current flowing that way. It can't backfeed the other way, so that should be safe. let's plug these bananas into here. Unfortunately, this results in a very unwieldy long setup. And then I can connect the other end of this cable into here. This should be safe. Let's do it. Yeah, that's fine. So this will is current limited to 1 amp. So 1 amp might be quite fast actually. Let's try it. 3.7 on my dodgy cell. Oh, that's not shooting up too quickly. 3.72. So I'll keep an eye on that. Immediately we've got the 3 to 4 lights coming on. So I presume it's actually trying to bleed from 3, which is going quite high, and transfer to 4. Now, is this getting warm? Because this should be transferring at the higher current. Yeah, this is okay. This isn't shooting up too quickly. What have we got here? Oh, that's current limited, so we've got 1 amp. And that voltage is not really representative because it's got 2 diode, Schottky diode admittedly, but 2 diode drops between the power supply and this. So what we really need is a voltmeter across all of this. I suppose I could put my DVM on it, but anyway, it doesn't really matter. We know it would be just this plus 2 volt drops, which are about, I don't know, 300 millivolts, something like that. So yes, I can charge this as well, and the balancing board kicks in. It's not attempting to transfer from 3 down to 2. Doesn't appear to be. Not quite sure why that is, but anyway, yes, I can charge it. Let's turn that off and see how long it takes for that light to go off and everything to balance up and recover. Now, if I want ammeters on here to see the current of the energy being transferred from cell to cell, it would become even more unwieldy. So I'll probably use this, which is a clamp ammeter. There's a 40 amp range. Unfortunately, this is not illuminated, so I can set that to 0 and then clamp. Well, it's saying 3 to 4, so the most positive wire, positive I suppose, on there. And that's showing, well, it's all over the place. That's the problem, because these things are not terribly precise and they are subject to magnetic fields, and they do vary a lot. It's not really saying anything. It's saying 0.02. That's nothing. Let's try the next wire back, which is the white wire. Oh, that's saying 150 milliamps. So now why would it be 150 milliamps on the white wire but not anything significant on the red wire? The red wire being, yeah, that doesn't make a lot of sense, does it? Oh, that's gone up to 200 milliamps now. But then this thing just has a habit of wandering like crazy. Yeah, that's drifted since I originally set it. It's just magnetic fields affect the little Hall effect sensor in the end there. Yeah, so maybe this thing's not going to be any good. And I will need some LED ammeters, but the number of 9 volt batteries I'm going to need is just going to be ridiculous to look at all the voltages and currents between various parts of the circuit. Ugh. Aha, that light has just gone out. This has settled back slightly higher than it was before. I think it was about 3.6. Of course, it's had a bit of energy pumped into it from my power supply, but yeah, that's switched off. And now we'll just sit there and do nothing, presumably, because these cells have sort of all settled down. So finally today, because I can't do much more until my voltmeters arrive, let's put the load on there again and just watch this voltage fall, and then wait for the balancer to notice, oh, it has already, that there's something wrong. And yes, the 2 lights either side, well, the transfers that involve cell 3 have both started up, but now that one has started up. A transfer either from 2 to 1 or 1 to 2, I'm not sure which, and I'm not sure why. But I'll leave it there for today. I can play with this more when my voltmeters arrive. Cheerio.